Now I am Gatwili. Now I will talk about the main memory capacity. Main memory capacity of a computer is defined as the number of bytes that can be stored in its main memory. It is represented normally in terms of kilobyte KB, cap KB, which is equal to 10 to 10 124 or 2 to the power 10 bytes of storage, and megabytes, which is represented by cap MB, and it is equal to 1,48,576 bytes of storage or 2 to the power 20 bytes of storage. Similarly, gigabytes, which is equal to 2 to the power 30 bytes of storage. Therefore, a computer having 2 GB of memory is capable of storing 2 into 2 to the power 30 bytes of storage or characters. Notice that 1 KB is about 10 to the power 3 bytes, 1 MB is about 10 to the power 6 bytes, and 1 GB is about 10 to the power 9 bytes. Sometimes we also state memory capacity of a computer in terms of words. In this case, we specify total number of bits per word along with total number of words. Therefore, a memory with 4096 locations, with each location storing 16 bit, is called a 16-bit 4096 word memory, or 4K 16-bit memory. Similarly, a memory having 2 to the power 15 words, with each word of 16 bit, is called a 32K 16-bit memory. If word size of a memory is 8 bits equal to a byte, it becomes immaterial whether memory capacity is expressed in terms of bytes or words. Hence, a memory having 2 to the power 16 words with each word of 8 bits is simply referred to as a 64K memory, where word size of 8 bits is implicit. Now the types of memory chips. Memory chips are classified mainly based on their capability to retain and store data when power is turned off or interrupted, and how easily stored data can be altered or overwritten. In figure we see various types of memory chips. This is the figure of memory chips. Now, first we see the random access memory. Basically, this memory consists of some integrated circuit IC chips, either on motherboard or on a small circuit board attached to motherboard. A computer's motherboard usually has flexible to easily add more memory chips for enhancing the memory capacity of the system. Hence, if a user decides to have more memory than his or her computer currently, he can buy more memory chips and plug them into memory slots on the motherboard. Normally, service engineers do this job. additional RAM, random access memory chips, which plugs into a special socket on motherboard are known as single in-line memory modules, SIMM. Single in-line memory modules. In this module you can add chips into a special sockets. Now the RAM chips, random access memory chips, are of two types, dynamic and static. The dynamic RAM, DRAM, which is also called DRAM, uses an externally circuit to periodically regenerate of or refresh storage charge to retain the stored data. On the other hand, a static RAM, SRAM, does not need any special regenerator circuit to retain the stored data, since it takes more transistor and other devices to store a bit in a static RAM. These chips are more complicated and take up more space for a given storage capacity than dynamic RAMs do. Moreover, on a static RAM, a static RAM is faster, costlier, and consumes more power than dynamic RAM. Due to these reasons, large memories use dynamic RAM, and a static RAM is used mainly for specialized application. The main memory of most computers uses dynamic RAM. Thus, we can see that the memory chips are of two types, volatile and writable, which is called also writable, and second is non-volatile and read only. Now volatile and writable have of two types, having of two types, that is static and dynamic. That is volatile or writable memory is called RAM, and a static RAM, that is SRAM. Similarly, dynamic is called volatile dynamic RAM, DRAM. Now, non-volatile and read-only memory is of two types. Manufacturer programmed ROM, read-only memory, it is also called read-only memory, and user programmed, which is PROM and EPROM, programmable read-only memory, and EPROM, erasable programmable electronically programmable read-only memory. And then EPROM is of two types, UV EPROM and EEPROM. So see this one by one. So first we talk about read-only memory, ROM. It is a special type of RAM called read-only memory, ROM, and is a non-volatile memory chip in which data is stored permanently. Usual programs cannot alter this data. In fact, storing data permanently into this kind of memory is called burning in of data, because data in such memory is stored by using fuse links. Once we burn fuse links for some data, it is permanent. We can only read and use data stored in a ROM chip. We cannot change them. This is the reason why it is called read-only memory, ROM. Since ROM chips are non-volatile, a ROM chip does not lose its stored data in case of power off or interruption of power. This is unlike a volatile RAM chip. ROMs are also known as field stores, permanent stores, or dead stores. System designers use ROMs mainly to store programs and data which do not change and are used frequently. A computer carries out most of its basic operation by wired electronic circuit. However, several higher level operations used frequently require complicated electronic circuit for their implementation. Hence, instead of building electronic circuits for these operations, designers use a special program to perform them. These programs are called micro programs because they deal with low level machine functions and are essentially substitutes for additional hardware. Computer manufacturers store these micro programs in ROM so that user cannot modify them. A good example of macro program is the system boot program, which contains a set of startup instructions that are executed when a system is powered on to check if the system hardware like memory, IO devices, etc. is functioning properly or not. It looks for an operating system and loads its core part in the volatile RAM of the system to produce the initial display screen prompt. Note that the computer needs this micro program every time it is switched on, and the computer must retain it even when it is switched off. Hence, the computer's ROM is an ideal storage for this micro program. The next memory chip is programmable read-only memory, that is PROM, PROM, PROM. Now, there are two types of read-only memory, ROM, ROM, manufacturer programmed and user programmed. A manufacturer programmed ROM is one in which data is burnt in by the manufacturer of the electronic equipment in which it is used. For example, a personal computer manufacturer may store the system boot program permanently in a ROM chip located on the motherboard of each PC manufactured by it. Similarly, a printer manufacturer may store the printer controller software in a ROM chip located on the circuit board of each printer. It is not possible for users for such equipment to modify the programs or data stored in the ROM chip. On the other hand, a user-programmed ROM is one which a user can load and store read-only programs and data. That is, it is possible for a user to customize a system by converting his or her programs to microprograms and thus storing them in a user-programmed ROM chip. Such a ROM is known as programmable read-only memory (PROM) because a user can program it. Once the user programs are stored in a PROM chip, the system can execute them usually in a fraction of the time previously required. A special device known as PROM programmer is used to program a PROM chip, that is to record information on it. However, once a user programs a PROM chip, it becomes a ROM. That is, the information recorded in it can only be read, it cannot be changed. PROM is also non-volatile storage, that is, information stored in it remains intact even in the case of power is off or interruption of power. Next is memory chip is erasable programmable read-only memory, EPROM. Erasable programmable read-only memory, EPROM. Once information is stored in a ROM or PROM chip, a user cannot alter it. Now to overcome this problem, there is a solution for this, and this is called erasable programmable read-only memory, EPROM chip, and it allows user to reprogram it easily to store a new information. Research and development personnel, experimenters, often use erasable programmable read-only memory because they frequently change microprograms to test a system's efficiency with a new program. Now, EPROMs are also useful for those applications in which one may like to store a program in a ROM that would normally not change, but under some unforeseen condition, one may like to alter it. When an EPROM is in use, the user can only read the information stored in it, and the information remains in the chip until the user erases it. So EPROM chips are of two types. The first one is ultraviolet EPROM or UV EPROM. Ultraviolet erasable programmable read-only memory, which requires exposing the chip for some time to ultraviolet light for erasing information stored in it. And the second one called electrically EPROM or EEPROM, which requires use of high voltage electric pulses for erasing information stored in it. So it is easier to alter information stored in an EEPROM chips as compared to an UV EPROM chip. EEPROM is also known as flash memory because of the ease with which a user can alter programs stored in it. Many new IO and storage devices like USB, universal bus, serial bus, and also called pen drive, and MP3 music player use flash memory. So here we know that the flash memory is EEPROM, that is electrically erasable programmable read-only memory. EEPROM is known as flash memory. The next one is a cache memory. Now the next topic we will see the cache memory. What is cache memory? We saw that the use of main memory helps in minimizing the disk processor speed mismatch to a large extent because the rate of data fetching by central processing unit from main memory is about 100 times faster than that from a high speed secondary storage like disk. Still, the rate at which central processing unit can fetch data from memory is about 10 times slower than the rate at which CPU can process data. So the performance of processor often gets limited due to this memory processor speed mismatch. Clearly, we can improve the overall system performance greatly by minimizing the memory processor speed mismatch. Now, cache memory, pronounced cache, is commonly used for this purpose. It is an extremely fast, small memory between central processing unit and main memory, whose access time is closer to the processing speed of central processing unit. It acts as a high-speed buffer between central processing unit and main memory, and computer system use it to store temporarily very active data and instruction during processing. Since cache memory is faster than main memory, system performance improves considerably when the system makes those data and instruction available in cache that process need during their present processing.